Hi, welcome to the channel. I'm Mrs. R. Let's do some math. Today we're talking about discrete relations. Now, a relation is just a way to get from one group of things, like this stack of colors, to another group of things, like this stack of letters. Now, these are relations between sets. So when I say group of things, these are generally sets of things, but they can be sets of pretty much anything, like colors and letters, numbers, expressions, all kinds of different things. But there's always a specific rule for this relation. Now, this relation I'm showing here, I apologize, is not a good example if you are colorblind, because I have on this left side a bunch of colored dots. But my relation here, how we get from colored dots to letters, is the first letter of the color name. So if you see, we start with a color, like red. So our first one is red. I can map that. So down here, I'm going to have a bunch of arrows. These are called our map. Arrows that take me from the start item, we're going to call that the input, and take it to its corresponding finish or output. So red is going to line up with R because red starts with R. That's our output. And we can do the same thing. The next color is orange. So I can draw an arrow from the orange dot to the O. Sometimes you put the actual arrows, sometimes you just connect them with a line, but yellow would connect to Y. Green starts with G, so we'll connect that. Now blue is going to go to B. Purple will go to P. Black is going to go up to B, and brown is going to go up to B. This is called a mapping diagram for a relation. Sometimes you'll be actually told the rule, sometimes you'll just look at the mapping diagram and have to infer the rule. This time I told you the rule was first letter. So our map is taking each colored dot and drawing an arrow to its first letter. Now, things to notice, each colored dot only has one arrow coming off of it. That's important. And we also can see that some of these letters have multiple arrows going to them. Now, that's not super important for an Algebra 1 level relation discussion and as we intro our functions. Not super important in Algebra 1, but if you are in Algebra 2 trying to get a refresher on relations and functions, having multiple arrows going to a single output does get important for you. So this was one example of a relation. Here's another example of a relation. So I have 4 words and then 4 letters. Now, if you wanted to pause the video and try and guess what my rule is, what my relation is, you're welcome to. But I won't make you wait. What we're looking at here is letters that are doubled. So here's my input. My input are these words. And then I'm looking at doubled letters for my output. So albatross has a double S. So albatross maps to S in this relation. Green has double E, so green maps to E. School has a double O, so it maps to O. Success, though, success has double C's, so it maps to C. But it also maps to S because there's the double S at the end. So this is another mapping diagram of a relation. We have an input set. We have our relation rule that takes us to our output set. Now there is a significant difference between this relation and the colors relation that we did just a minute ago. Namely, the fact that all of our inputs in the top one had exactly one arrow coming off of them. They map to exactly one thing. If I tell you a word, there is one first letter, and that's always the first letter. In our second one, though, when we said doubled letters, in some words there were multiples. So we didn't automatically know which map was going to be the one we were looking for. There's a little bit of ambiguity if you have 2 arrows coming off of a single input. So to kind of emphasize this distinction, we have a new vocabulary word that's called a function. So a function is just a relation, like we've talked about two relations, in which each input maps to exactly one output. So when we consider our two examples up here, the one with the colors at the top, that one is a function. Each color name has exactly one first letter. The second one, though, is not a function. It is still a relation. There's a rule that gets us from input to output, but it's not specifically a function. So the rest of what we're talking about today is just kind of dealing with those functions, identifying them, creating diagrams for them. This is another way, especially in your math class, where you might see relations mentioned. X is always your input. Y is going to be your output. And you might be asked to look at the table and decide if this relation is a function. Now, we don't know the relation rule here. I don't know how they started at -7 and got to 1 and did the same thing to get from -3 to 0. I don't know what the rule is, but I can see they started at -7 and that took them to 1. They start at -3 and it maps to 0. They start at -2, it maps to -1. So remember, if you're trying to decide if it's a function or not, you look at all the inputs, and does each input go to exactly one output? So -7, if we start at -7, you know we're going to 1 because there's no other -7s down the list. Same for -3. There's no other -3s in the list, so we know if we have -3, it'll map to 0 every time. So in a table, you don't see the arrows, but you're really looking for unique inputs. If all of the inputs are unique and they have an output, then this is a function. In the next table, we start to look at that. We see, okay, -2. There's no other -2s, so we know -2 always maps to 7. There's a 0, no other zeros, so 0 always maps to 1. 3, same thing, but now we have this double 7. So here's where we have to be careful. Now, this doesn't automatically mean it's not a function. It just means, let's look at this. So we have a 7. Here it maps to -2. Here it maps to 0. -2 is not the same as 0, so those are two different outputs, which means not a function. Now, sometimes in these tables, especially if it's data that you've collected from something, you might see repeated inputs like the double 7s there, but you might also have repeated outputs. So if this was 7 to 5, and this was also 7 to 5, that would still be a function even though you're seeing the repeated inputs because 7 is always matching up with 5. So that's kind of the idea with looking at a relation and deciding if it's a function. Check the inputs. Does each input go to exactly one output? Now, another thing you might be asked to do is if you're given a set, you have to kind of make a diagram for it, and that helps you determine if it's a function or not. So there's two different ways a lot of times that they ask you to do this, sometimes in a table, sometimes in a mapping diagram. So I have both for this example. The table honestly is a little bit easier. You do want to try and get your X values all in numerical order because that'll just make it a lot easier to check for those repeated inputs. So I'm going to look for the smallest X value, and I think these actually go in order for X value. So our first one, -1, 2, second one, 0, -3, 0, 2. And I'm just putting the coordinate points in a table. So my first numbers are always X's, they go on the left. My second numbers are always Y's, they go on the right. So then I can look and say, okay, is this a function? -1, I only see once. 0, I see twice. So remember, that doesn't mean it's not. It just means, hey, let's check this. We've got double zeros. But then we look, 0 maps to -3 and 0 maps to 2, and those are not the same. So this is not a function. And that's how you work from a table. Now, if we were asked to do the same thing, but using a mapping diagram, that's what those two ovals are over there. Kind of the same idea, but you work with sets instead of just the table. So what we'll look at, we want all of the x's to be in a list in the first oval. Now, if you keep them in order, that's fantastic. It's kind of the idea of these, put them back in order. So -1, 0. Now there's another 0, right? But we already have 0 on the list, so we can just put 0 one time. And then a 6, and then a 7. Those are all the different x values we have. Then we look at the y's, and again, we want to try to put these in order. If you want a really good mapping diagram, putting the numbers in order so you can find them is usually the way to go. So -7 is the least. Then there's a -3, a -2, and then there's 2 different 2's. But again, we only have to put that in there one time because 2 equals 2. So I have all of my numbers. I have my sets built for this. Then to actually map them, you look at the points. So our first point, -1, 2, means we're going to put an arrow from -1 to 2. Then our second one, 0, -3, we're going to put an arrow from 0 to -3. Our third point, 0, 2, we're going to take an arrow from 0 to 2. 6, -2. And 7, -7. And now I have my mapping diagram done. If you're trying to tell from a mapping diagram whether this is a function or not, remember you are looking for, does each input map to exactly one output? So focus on the inputs, and you're checking how many arrows come off of that number. So on our 1, there's only 1, but 0 has 2 arrows coming off of it, which means this is not a function. We don't even have to check the other ones. As soon as you find an input that has more than one output, then not a function. Now, we had already looked at the table. We already knew this was not a function. But now you can see both ways of doing this. So that is our kind of primer on relations and intro to functions. So thank you so much for watching this video. If you did find this video helpful, please like it. That helps our videos reach more people. And if you still have questions, leave a comment for me. If you want to see a different concept, leave a comment and we'll try to get that video posted as quickly as we can. But I'm Mrs. Robertson and this has been me doing math. Thanks a lot. We'll see you next time.